So this is the start of Unit 2, Exponential and Logarithmic Functions. Today we're going to look at just exponential functions and their characteristics. So we have our general form here. We'll talk about it more in depth in class. An exponential function is when the exponent is the variable. We have b, which is called our base, and a, which is the initial value. So taking a look at these, let's figure out which ones are going to be exponential. You could check the graph, or we could just analyze the function as it is. I'm going to cross off the ones that aren't exponential functions. You can cross off g of x. The variable is not in the exponent. Oops. We can cross off q of x. No x at all in there. That's actually a constant. The only one left that might look a little troubling, besides k of x with a negative, that's okay, is this p of x right here. If you think about what the radical is telling us, we could actually change that into an exponent, change it into 7 to the x to the 1/2, which really becomes 7 to the x over 2, so we're all good. The exponent is still the variable, it didn't change into a square root function or anything like that, we're good. So let's take a look at a table and see if we can figure out what the function is. So we need an a and we need a b. We know that the a value here for, let's start off with g of x. The a value, or our starting value, is 4. And then we want to figure out what the base is. So we're going to look at what's being multiplied by repeatedly. It looks like we're being multiplied by 3. So we have g of x equals 4 times 3 to the x. For h of x, our initial value is 8. And our common ratio here, or our base, looks like we're dividing by 4, which we're going to write as multiplying by 1/4. So just to recap, the 8 goes here, the 1/4 goes here. 4 goes here, and the 3 goes here. We call something growth when the rate of growth is increasing. So like bacteria growing, which you can see in the background, invested money, population growth. We call it decay when the rate of decay begins very steep and then levels off eventually. Depreciation of value or radioactive half-life, which you can see in the background, are two examples of exponential decay. You can tell by looking at the function if it's going to be growth or decay by looking at the base. Base is greater than 1 will be exponential growth. Base is less than 1 will give us decay. The a value does not affect this, but if we have a negative a value, it's going to flip the graph over the x-axis. The same thing will happen if you have a negative x in the exponent. So the last part is looking at the characteristics. We want to think about what our domain, range, whether or not there are any intercepts, if it's continuous, if it has any symmetry, are there our maximum and minimum values, are there any asymptotes, and is there any end behavior? I'm going to use the parent function for these two. So just talking in general, this might change depending on what the actual function looks like. So for growth, the domain Well, we can use all real numbers here. The range, if this is for, if it hasn't been shifted up or down, the range is going to go from 0 with a round bracket to positive infinity. There aren't any x-intercepts in the parent function, but there is a y-intercept, and the y-intercept is going to happen at a. So actually, let me write that a different way. As a point, this will happen at 0, a. Yes, it's continuous, and there is no symmetry. There are no maximums or minimums. There are asymptotes. There's a horizontal asymptote at x equals 0. And for the end behavior, as x approaches negative infinity, f of x approaches 0. That's kind of the asymptote there. And as x approaches positive infinity, f of x is going to approach positive infinity as well. Most of these are going to be the same for decay. We have the same domain, same range, same intercept. Yes, it's continuous. Yes, there's symmetry. No, there are no maximum and minimums. Yes, there's an asymptote. The only thing that's going to change is our end behavior. So as x approaches negative infinity, boy, that got bad, negative infinity, f of x will approach positive infinity, and as we move to the right, the function is now approaching 0. So those flip. If you need help with those, remembering end behavior, I'm going to put a star next to this because you need to remember to ask me to review that with you. That's it for us today. I don't have any try on your owns because I felt like that was pretty basic stuff. If you have questions for me, though, don't forget to ask when you get to class, and don't forget to submit Google form or take your notes.